We talk about what today? Raise your hand if you want to answer, please. Okay, Award, go on.
Today we took making algebraic expressions with algebraic tiles.
Exactly. We will represent algebraic expressions by using algebraic tiles. And then we will start to represent this equation. So the equation said 2x plus 2 equals 6, right? Then we said that we are going to translate expressions into tiles like this. Then the large rectangle represent positive x. If it's positive, we will draw it's yellow, and it depends on the color which you are going to choose. So it's up to you to choose the colors, but you have to mention the key for your choice. Then for ours today, we choose to put positive x. We choose the yellow one, and then the red one, it will be by negative. And then the second, if you have a negative number, we will put a small square with negative, and if it's positive, it will be a small square with positive. Then the first question was 2x plus 2 equals 6. We will choose 2x, then we are going to go and pick two yellow colors or two yellow rectangles together like this, and then plus 2, it will be a two small rectangles, and then we will put them. And then in the other side I have 6 positive, so we put 6 yellow rectangles, sorry, squares or small tiles, I mean. So this is how we are going to write, because in our lesson today we want only to write. We will not solve, we want only to write the equation by algebraic tiles. Understood, grade 7? Understood?
Yes.
Let me give you another example. Please, you will try to solve it first. You will try to solve it first. So we have a new question. I'm going to write it to you. 2x minus 4 equal 10. 2x minus 4 equal 10. We will choose first what? We will choose first what? The key. Okay? So we will choose the key. We have to draw the key first. So we have large, and then we have a small. Okay, we will donate the large one now, this one, by what? By positive. We will say that this one is positive. The red one is positive, and this one is negative, positive, and this is negative. But the large one, this is for x, and this is for what, grade 7? For negative x. And this is 1, and this is negative 1. Could you please tell me how we can translate this equation? How we can translate this equation to be algebraic tiles? Huh? What is the first step, grade 7? Okay, يا مروة, go on حبيبتي.
Two big tiles, positive.
Okay, first we will draw a big rectangle like this. Okay, so this is the first step. Second, we will divide it. the big rectangle into two parts. It's not necessary to be equal, but we will divide it into two parts. Let's start, Yamar. The left side, we have what?
Two positive pictiles.
Okay, two big positive big tiles, which means I have two large rectangle. Which color?
Red.
Red. Yes. So this is one, and this is two. Okay. After that, ya Marwa?
Four small negative.
Yes, four small negative, then four yellow, one, two, three, and then four. What about the opposite side? What about the opposite side? What we have to put?
10 small positive.
10 small positive. One, two, three, four, five, six, seven, 8, 9, 10. Right? Then, thank you, ya Marwa. How we are going to write an equation by using algebraic tiles. As I said, we have to put the key for our work at the beginning. How? This is the key for our work. It depends on the key we are going to translate. How? I have now this large rectangle means positive x. If it's red, so we will say that this one is positive. If it's yellow, so it's negative. Second, we have the small squares. It will be also represent one positive and one negative. How we will translate an equation? We will translate an equation by using algebraic tiles like this. Then I can give you the opposite. Then maybe I'm going to give you a question like this at the beginning. I will not write the equation. Okay, so this is the second type of questions. I can write for you that this one is positive and this one positive. This is negative and this is positive. So how we are going to translate an equation in this case, grade 7? How we can translate an equation in this case? Who can repeat? How we can translate a drawing for algebraic tiles to be an equation? In case if the question will come like this and the question will ask to write the equation, we will look at the key. Yani for sure here we have the key at the beginning. We said the key that this one represents the positive, the red one, and this one represents the negative. Okay, and then we have two small, one, and then the other one is red like this. Okay, so the key said that this one, the first one is positive, and this one is positive 1. This is positive what? A long bar for x. Okay, a long bar for x. And this is for negative x, and this one for negative 1. Okay, I want to translate now. So what this? I have two red large rectangle. So this is 2x. I have 1, 2, 3, 4 yellow. So this one is negative 4. Then equal. I have 10 small square. So this one represent 10. Understood? It's your turn now. I will give you another equation. You will try to draw it and then send it to me in our WhatsApp group, please. Quickly, it's your turn now. I will write the equation. Ready? If you are ready, raise your hand. 3x minus 4, 3x minus 4 equal 2x plus 6. 3x minus 4 equal 2x plus 6. What do you notice here, grade 7? What do you notice, grade 7?
There is two equations.
It's not two equations, it's only one equation, but we have x in both two sides. We have x in both two sides, right? Then we will start to draw. What is the first step? Could you please tell me?
The big rectangle.
Yes, we have to draw the bigger rectangle. Thank you. And then we will divide.
Divide it into two pieces.
Thank you. We will divide it into two pieces. Then we will start to translate our equation. Our equation now, we have what? We will start with what? You will pick up?
Yeah, 3x.
3x.
3 big positive rectangles.
Thank you. Marwa's talking?
Yeah.
Yeah. Okay, so I have this is 1, and then 2, and then 3. Okay. And for the other side, I have how many?
2 big positive rectangles.
Yes, 2 big positive rectangle. Thank you. 2 big positive rectangles. So I have this is 1, and then this is 2. Okay. And then we will start to translate.
What? 4 small negative rectangles.
4 small negative rectangle. It will be yellow. 1, 2, 3. Oops, too large. 3, and then 4. Here in this one, what about the other side?
6 small positive rectangles.
6 small positive rectangles. So this is 1, 2, 3, 4, 5, and then 6. So this is how we can translate. Now, even if I will not try inside the rectangle that this one is positive, I'm going to I'll back to the key, and the key told us that the longer rectangle means positive x, and the smaller one means positive 1. And this one for the other side, I have the yellow is negative rectangle, and the other one is negative 1. So this is how we can translate an equation by using algebraic tiles. Now we can say, if I want to answer this question, I have two sides, right? And I have 3x in the left side, and I have 2x in the right side. Is there anyone can tell me how we can solve this equation now? If I have the algebraic tiles in both two sides like this, how we can answer it? Is there anyone can suggest the answer? Let me say
Can you say it again?
Okay. I have this algebraic tiles now. I have this equation in front of us. If I want to solve this equation now, we already wrote the equation, right? We already wrote the equation. I want to solve it. I want to know I want to know if this equation now, how we can solve it. So we can cancel one from each side. We have positive and positive in both sides, right? We have positive and positive. Then
Yeah.
I can come now and I will cancel one from the left side and one from the right side. Do you have another, or it's different? You have another x, or it's finished?
Yeah, another X.
Another x. So I'm going to remove one from the left side and I will remove one from the right side, because 1 minus 1, if I will transfer them, so one positive and one negative. Did you remember this is called what? This is called zero pair. Did you remember? Zero pair. One
Yeah.
positive and one negative, we can cancel them together. Now, in the left side, I have only one x, right? What about the value of the small tiles? We can cancel or not?
We can.
We can cancel or not?
Yeah, yeah.
No, we can't. Why?
How?
Why? Because the left side, it has negative, and the right side, it has positive. So I can't cancel. Okay? Why we can't cancel? Because we canceled only from each side the items or the bars which they have the same sign only. So, Miss Sahar, what we have to do to solve this equation? We are going to put the zero pair for the smaller part, which means -4 in the left side. I'm going to add to it its additive inverse. What is the additive inverse of -4?
4.
+4, right? Then I will
Mm-hmm.
add to the left side, I will add +4, and I will add to this side +4. Now, how we can translate it in algebraic tiles? Okay, you will go and you will pick up 4 small units, which means I'm going to draw here in this side. I will draw 1, 2, 3, 4. And don't forget that you will draw in both two sides. So I will put 1, 2, 3, and then 4. Okay, then I started already to add the the additive inverse for both. What is the next step? The next step, we have to cancel now, because this is +1 and this is -1. Did you remember? Zero pair. So I will start to cancel now. One positive with one negative, one positive with one negative, one positive with one negative, one positive with one negative. Then for in your left side now, you have how many? I have only x equal. What about the other side? I have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then x equal how many? Then x equal 10. Okay, so first we will represent the equation by algebraic tiles. Second, I want to solve the equation by using the algebraic tiles. Then if you have in both sides, if you have the same algebraic tiles, the same positive and positive, so we can cancel them. But if you have different, we will add the additive inverse. Okay, let me show you another question. Understood this part, grade 7?
Yes.
Let me give you another question. I have 2x. Please write the question. The question is 2x plus 4 equal equal 6. 2x plus 4 equals 6. First, what we have to do? What we have to do first? We will draw,
The big rectangle.
yes, the large rectangle. And then I'm going to divide a large rectangle into 2 parts. We know the key now, right? How we will translate it by using algebraic tiles? How we will
And the left side, 2 big positive rectangles.
Yes, 2 big positive rectangle. So this is 1. And then I have another 1. Then what else?
2 small 4.
Yes, 2
positive.
small 4 positive. So this is 1, and then 2, and then 3, and then 4. The opposite side I have
6 small rectangles.
6 small rectangles. So this is 1, 2, 3, 4, 5, and then 6. Okay. So this is how we translate an equation by algebraic tiles. Second, we want now to solve the equation. Do you have any x in your left hand? Do you have any x in your left hand? We don't have, right? We will look at the number. I have 4. How we are going to remove 4? We will use what? We will use what?
We're going to cross it with the positive 6.
Cross it with positive 6? We can cross with positive 6. Why? Because already we have both of them
Or positive?
Yes, very good. So this is the idea that we can cancel. Now I have 1, 2, 3, 4 with 1, 2, 3, 4. Exactly.
So the answer is going to be 2x plus 2x equal 2.
Excellent, excellent. Yes. So the next step we have only, it will be 2x, which means the large bar. So we have 2 2x, it will be equal 2, 1, 2. It will be equal how many in the other side? 1, 2.
2 small positive.
2 small positive. Now, which means each 1x, it will represent how many? Each 1x, it will be equal how many? Each 1x, the solve for this, if I will distribute each algebraic bar with one small, this is 2x and this is 2, which means each 1x, it will be equal, each 1x should be equal 1, right? So this is the answer. This is the answer for the equation. Then x equal what? Equal 1. Okay, so we said at the beginning that we have 2 bars, 2x plus L4 equal 6, and then we can cancel because they have both have the same sign. Then we can cancel 1 with 1, 1 with 1, okay, and then till I will cancel the 4 small rectangles. And then we will say that 2x equal 2, then each 1x, it will be equal 1. We can also say, if you want to add an additive inverse, that I will add additive inverse for 4, it will